In lesson 9-1, we will write algebraic expressions to determine any term in an arithmetic sequence. So arithmetic meaning it's adding each time. They call it a geometric sequence if from one term to the next it's multiplying. So sequences is what we're going to be focusing on. You know, if it goes like 2, 4, 6, 8, and that will continue, we should be able to find, you know, any term number out there. If I ask you for the 150th term, we should be able to figure that out without counting all the way up 150 times. Term is what I was referring to there, meaning what term is this? 2 is the first term, 4 is the second term, 6 is the third term, 8 is the fourth term. So term is referring to which spot it's in the sequence. So sequence would be what numbers are actually there. Term is what order they're in. Arithmetic sequence is just referring to the fact that they're adding. And then common difference refers to how much they're adding by. So here it's plus 2, plus 2, plus 2. So the common difference is 2. And common difference, I'd like you to also associate that with the coefficient of a problem. Okay, and basically what we're talking about here is slope. Any sequence can usually be graphed as a function, and the common difference is how much it's either increasing or decreasing by. And when we refer to that, we're referring to, you know, what is it going up or down on the graph. And so again, we're talking about the slope of the line. So state whether the sequence given is arithmetic, and if it is, state the common difference. So when I look at this, first I'm going to go ahead and copy this down. 23, 15, 7, -1, -9. All right, so from 23 to 15, it looks like we're subtracting 8. Same thing here, subtracting 8, and then another -8. So this is an arithmetic sequence. It doesn't have to be addition. It could be subtraction as well. The common difference is -8. So common difference equals -8. And then it says write the next 3 terms of the sequence. So if I kind of put 3 blanks here for myself, if I subtract 8 again, I'm going to get -17. Subtract 8 one more time, -25. And subtract 8 one more time, I'm going to have -33. Those will be the next 3 terms. So you have a couple different answers here. Common difference is -8, and your next 3 terms are -17, -25, and -33. For your homework on a problem like this, you know, as long as you're showing me this work here, I'm fine with that, and then I'll be able to know the common difference is right here. You can even say kind of CD for abbreviation, and kind of put an arrow to it. That's your common difference, and then your next 3 terms, make 3 blank lines and write the next 3 terms for me. Now it says write an expression that can be used to find the nth term of the sequence 0.6, 1.2, 1.8, 2.4. So you see here we kind of have some work done for you. The term number, 1, 2, 3, 4, and then the term is 0.6 plus 0.6 plus 0.6. So it worked out that it was 0.6. So again, the common difference is your coefficient. So we're going to say 0.6n. Okay, so right away, whenever you're figuring out the nth term, whatever the common difference is, that gives you your coefficient. And then what you have to do is you have to take your first term and plug it in for n to make sure that it works. Because you could actually have like 0.9 or something here. And if you have 0.9, then it would be 0.6 times 1 is 0.6. And well, I got to get it to 0.9, so then you'd have to say plus 0.3 to get it to 0.9. And that would be your expression. However, we don't have that because 1 times 0.6 is 0.6, and that is my first term. So then what I suggest you do is you just take your calculator and plug in the 4th term or any other term in the sequence to make sure it still works. So 0.6 times 4 is 2.4, and that does work. So this is the expression for this sequence. So Just be sure you're trying other numbers other than just 1. Use 1 at the beginning to make sure it works to set your expression, and then use any other term in there to, again, just check your answer. All right, so 3, the miles, we're going to represent that as our term. And then this is where we're going to check to find if there is a common difference for us. So this arithmetic sequence shows the cost of a taxi ride for 1, 2, 3, and 4 miles. What would be the cost of a 9-mile ride? Well, we don't want to just keep adding it up. So what we're going to do is we're going to find n, and then we're going to use that to find 9 miles. So here, if we take, what is the difference of 5.25 and 7? Well, it would be $2 if it would be $5. So we're looking at a $1.75 difference. And here again, a $1.75 difference. And again, $1.75. So again, for n, we're going to use 1.75 n, and then take your first term and plug it in. Well, 1 times 1.75 is 1.75. So what is the difference between 5.25 and 1.75? We got to be able to add that extra to it. Well, I get a 0 there, and I'll have a 5 here, and a 3 here. So it's 1.75 times n plus 3.50, or 3.5. And this is the expression used to represent this sequence. Okay, now what does this mean? That means the taxi driver is charging $1.75 per mile, because remember, miles is our term. So $1.75 per mile. But right at the beginning, he charges you a flat fee of $3.50. So as soon as you get in the cab, you owe $3.50, and then you owe $1.75 for every mile after that. So what we're going to do is we're going to take 9 now and plug it in for n. If you want to, you could just go ahead and jump on your calculators for this. So we're going to take 1.75 times 9 plus 3.5, and that gives us $19.25 for our answer. So we'll just go ahead and write that in there. Okay, $19.25. All right, and so if you ride in the taxi for 9 miles, you're going to pay $19.25. Okay, so yes, we could have counted by $1.75 with our calculator and just kept adding until we got to the 9th term. However, if we jump to like 30 miles, how much would it be after 30 miles? You're not going to want to count up by 175 every time. So figuring out what this algebraic expression is to use it to determine other term values will be helpful for us in the future. And for our last example for today, what expression can be used to find the nth term in the following arithmetic sequence where n represents a number's position in the sequence? So this is basically just what we've been doing so far. Here's my n's. It's going up by 1, 2, 3, 4. So it's going up by 1 at a time. And this is going up by 3 plus 3 plus 3. So my common difference is 3. So I know I'm going to have 3n. Well, then take your first term, just plug 1 in. Because remember, this equals n. Okay, we're using 1 equals n, 2 equals n, 3 equals n, 4 equals n. So take your 1, plug in. 3 times 1 is 3. But what do we have here? We have a 2. Well, how can we get from 3 to 2? Well, you got to subtract 1. So 3 times 1 is 3, minus 1 is 2. Now check it with some other number. Let's check it with 3. 3 times 3 is 9, minus 1 is 8. So it does work. This is my expression for finding the nth term. Now, I do want to point out to you, what if we skip terms? Like, what if it said term 1 is 2, term 3 is 8, and let's say term 5 then would be, goes 2, 5, and then we'd be at 13. Okay? Well, you notice here, I'm sorry, you'd be at 14. Okay? Notice in your sequence that this is plus 6 and this is plus 6. What I want to caution you about here is it's not automatically 6n. Okay? The reason we could say just 3n right here is because look at what the terms go up by. They go up by 1. So plus 1, plus 1, plus 1. Here, notice we are skipping. We're saying plus 2. We're skipping a term. So that means whatever you get for a difference, you have to divide it by 2, or divide it by however many your terms are skipping by to get your 3. Okay, and then that 3 is the same as this 3. These two sequences that I've made here, that I've shown you, are the exact same sequences. It's just that here in this one, I skipped every other term. So I went from term 1 to 3 to 5. Now that's a common difference of 6, but if I went every term, it'd be a common difference of 3. So you'd still get 3n minus 1 for this term as well. So that way if I said, okay, what's the 8th term? You can plug in 8. 3 times 8 is 24, minus 1 is 23. You know the 8th term is going to be 23. All right, so if you have any other questions with the homework, check your step-by-step homework helper for all the odd numbered questions.